You know that feeling, right? You fire up a game, and this huge, incredibly detailed world just, boom, appears. Instantly. It feels like magic. But it's not magic. It's some seriously clever engineering. And today, we're going to pull back the curtain on the tech that makes it all happen.
I mean, seriously, think about it. How does a game like Doom Eternal throw you into these massive, complex levels in just a few seconds? How is it that when you respawn, there's zero waiting time? It's that kind of performance that makes an experience feel amazing, but behind the scenes, it is a monster of a technical challenge.
All right, so to really appreciate the solution, we first have to understand the problem. Let's get into what developers are really up against here, with what we can call the instant loading problem.
So here's the deal. You've got gigabytes and gigabytes of game assets. We're talking super high-res textures, super complex 3D models, uncompressed audio files, the whole shebang. And the game needs to grab any piece of that with basically no delay. Your standard database just can't do that. It's not built for that kind of speed.
Okay, so if the usual tools aren't going to cut it, what will? Well, it's time to introduce the hero of our story, a specialized tool built for this exact purpose, StreamDB. So what is this thing? Well, StreamDB is what's called a lightweight, embedded key-value database. It's written in Rust, which gives you that awesome combination of raw speed and memory safety. And its entire purpose, its reason for being, is to give you crazy fast, ultra-low latency access to binary data. It's a precision instrument built for one job, speed.
All right, you ready to pop the hood and see how this thing actually works? I promise, we'll keep it simple, no crazy jarting.
So, finding the data you need super fast is the first piece of the puzzle. StreamDB uses this really clever indexing method. Now, don't worry about the technical name. Just imagine you're looking up a word in a dictionary, but you're doing it backwards, from the last letter to the first. It sounds weird, but for a computer looking for a file path, it's an unbelievably fast way to pinpoint exactly what it needs.
And once it finds what it's looking for, where is that data stored? It's all neatly organized into these little 8-kilobyte chunks called pages. The best way to think about it is like a perfectly organized digital filing cabinet, where every single folder is exactly the same size. And that size isn't random. It's specifically chosen to be perfectly in sync with how modern NVMe SSDs love to read data. Okay, so it can find data in a flash, and it stores it super efficiently. But that's just the start. The real performance, the secret sauce, comes from its special set of features. Let's call it the low latency toolkit.
This is where the magic really happens. StreamDB's incredible speed comes from combining 4 powerful techniques. We've got streaming, compression, async operations, and prefetching. Let's break down what each one does. First up is streaming, and this is just brilliant. Instead of making you wait for a giant 100 megabyte texture to load completely, StreamDB lets the game load and use just the very beginning of that file. And while you're already seeing that texture in the game, the rest of it is still loading quietly in the background. For the user, it feels like it loaded instantly.
Next, we've got compression. StreamDB uses a super fast algorithm called Snappy that shrinks down all those asset files, sometimes by almost half. The logic here is really simple, right? The less data you have to physically pull off the disk, the faster everything is going to load. It's a massive win.
And then there are async operations. This one is all about making the application feel smooth and responsive. It pushes all that heavy data loading work onto a separate background thread. What does that mean for you? The main application never freezes up. You get no more stuttering, no more unresponsive interfaces while a massive file loads. It's just smooth.
And finally, we have prefetching. This is the really smart one. StreamDB is clever enough to predict what data you're probably going to need next, and it preloads it into a super fast memory cache before you even ask for it. So when you actually do need it, bam, it's already there. For things like video or audio that you read in order, this thing is scarily accurate, getting cache hit rates of 80 to 95%.
So, you take all of these features, you combine them all together, and what's the result? Well, when you flip it into its high-performance quick mode, you're looking at read speeds that are just staggering, up to 100 megabytes per second.
Now that incredible speed comes with an important choice. You see, by default, StreamDB runs in a safe and reliable mode. Think of it like driving with a seatbelt and all the safety features on. It runs integrity checks on every piece of data to make sure nothing is corrupted, giving you a very solid 10 megabytes per second. But quick mode, that's the nitrous button. It trusts that your data is good, skips the checks, and just goes for pure, unadulterated speed. So you have a choice: guaranteed safety or absolute blazing fast performance.
And a tool this powerful
Well, you can imagine its use cases go way beyond just making games load faster. This kind of technology is useful almost everywhere.
I mean, just think about it. You could have IoT devices streaming crystal clear audio in real time, or communication systems that log huge amounts of network traffic without ever skipping a beat. It's a total game changer for high-performance servers, and it can even make the apps on your phone or your desktop feel incredibly snappy.
And that brings us to the last point, which is about the whole philosophy behind this project. It's all about something we could call democratizing speed.
This is actually really important. The version of StreamDB we're talking about is what's called a clean room reimplementation. That's a fancy way of saying it was built from the ground up, based on public research and concepts. Nobody reverse-engineered or copied some company's secret proprietary tech. It's an open and frankly ethical way to build powerful tools.
And this quote from the project's creator really says it all. DMod's GPL v3 version democratizes advanced storage, ensuring open access to bleeding-edge tech. The entire goal here is to make this kind of mind-blowing performance available to everybody in the open-source world.
Which really just leaves us with one final question, and this one's for you. Now that you know how this stuff is possible, what could you build if you had truly instant access to your data? The possibilities are pretty amazing to think about.